The human body is a very complex system that has yet to be fully understood. As our brain sends electrical impulses through the nerves in our body, the signals are then transmitted to different body parts, allowing them to move. Keeping this in mind, professionals specializing in prosthetics can study the way the body works and moves and tie those into the development of new prostheses. While many advancements and improvements have been made over the years to prosthesis, the future of prosthetic limbs looks to be extremely promising, producing groundbreaking results no one would have expected. While prostheses today are just held together and functioning using three basic components, the most recent project being developed now and for the future is the biohybrid limb. Dr. Roy Allen, an orthopedic surgeon who directs the VA Brown Center, refers to the research and development of biohybrid limbs as a specific field known as neuroprosthetics, which is a part of a larger trend in prosthetics that aims to integrate the body, the mind, and the machine. In addition to the functioning mechanisms of the new prosthesis, there are also professionals working to improve the overall cosmetic appearance of the prosthesis, making them even more discreet than usual. The overall goal is to make it harder to decipher between a prosthetic limb and that of an original limb. Keeping in mind that teams of professionals specializing in orthopedics, prosthesis, neurology, and cosmetics are working to make the future of prosthesis not only more advanced for the amputee, but also conducive to the lifestyle that they lead. They are also encouraging them to be more active. In doing so, they plan to merge the new developments in the biohybrid limbs with the body so that the new limbs function and operate just as a normal limb would. According to Dr. Hugh Herr, director of the Leg Lab at MIT, the next generation of artificial limbs fuses directly to the human bone and are commanded by the brain, which also promises lightweight and natural motion. So, how does this process work and how will it be implemented? Professionals at MIT have coined the term bionic neurons, or BIONs for short. BIONs are special microchips that will be surgically implanted into the residual limb's muscle to pick up movement signals and nerve signals from the brain and send them to the artificial limb. In short, the brain can tell the prosthetic limb to move and which way it should go. Hugh Herr refers to it as a form of artificial intelligence because the brain signals are translated into actual commands for the artificial limb. According to Dr. Danielle Kirkovich of VA's Rehabilitation Research and Development Service, artificial limbs of the future will also feature sensory feedback to the brain. It won't be just the output, the residual limb telling the prosthesis what to do, but also the prosthesis reporting back to the chip and in turn to the brain what it did. So even if you weren't looking at your hand, you could sense that it reached down and grabbed a can of soda. In addition to the advancements already made to the future of prosthesis, sensory input and output are also being developed. In order to be able to compare prosthesis of the future with a normal limb, the amputee should also be able to touch and feel and sense things with the prosthetic limb just as they would a normal limb. Technology being tested today features a prosthetic limb with sensors to screen for how high a step is on stairs and how much force is needed to step up, the force of grip when grasping something, and finally being able to identify with temperatures such as hot and cold. Consistent with future technology, Dr. Danielle Kirkovich references a few other key medical techniques being implemented in prosthesis along with new robotics technology. Some of those include surgical techniques to lengthen the bone in the residual limb, which will make it easier to fit the artificial limbs and allow for greater control and mobility. Some forms of tissue engineering will help restore torn up joints. Techniques could include the use of biodegradable polymer beads, smaller than a pinhead, which would release proteins to trigger the production of cartilage and possibly bone. Lastly, osseointegration, which involves attaching prosthetic legs to a titanium bolt placed directly in the bone, which may help to avoid some of the problems of current methods. Without a doubt, the future of prosthetics is far beyond what anyone may have or could have expected. Full body prosthesis may be coming soon that will allow paralyzed individuals to also regain function in the limbs and muscles they have been told they will never be able to use again. Those who have undergone the loss of a limb and even future generations who may suffer a loss will not have to worry about the future and what it holds for them, because the future of prosthetic limbs paves the way towards their new beginning. For more information on the future of prosthetic limbs, Please visit biomed.brown.edu and you can read the article entitled Biohybrid Limbs, which is a publication from the Rhode Island Medical Society Journal. Thank you.